Welcome to the Explainer. Today, we're stepping into an absolute digital crime scene. We're going straight under the hood to mathematically prove exactly why AI models completely fail when you tell them what not to do. So if you've ever been frustrated because an AI hallucinated the exact thing you specifically asked it to ignore, you're definitely in the right place. Let's get into it.
All right, let's kick things off with a super quick psychological experiment. I have one very simple instruction for you. Ready? Whatever you do not think of a pink elephant. Seriously, clear your mind of it entirely. Push it right out.
But you just pictured one, didn't you? Yeah, it's practically impossible to stop your biological brain from doing that. And as it turns out, artificial intelligence suffers from this exact same flaw. Not emotionally, of course, but mathematically.
This is what experts call the pink elephant paradox in AI, and it's actually a severe mathematical vulnerability. When you apply a negative constraint, meaning you explicitly tell the AI to avoid a certain concept, you're virtually guaranteeing that the system is going to hallucinate it right back into your output. And today, we're using some absolutely groundbreaking new research from Anthropic to forensically prove exactly why this paradox happens right down at the bare metal hardware level. To really understand this digital crime scene, we first need to talk about a concept called associative bleed. Because of the way an AI's literal mind is built inside these continuous vector spaces, it's completely unable to cleanly sever interconnected data. It's like a giant woven tapestry. When you say the word elephant, thousands of invisible neural threads get pulled all at once. You simply can't delete a single thread without tugging on the whole fabric. And that is what causes those forbidden concepts to slip straight into the final output.
And this creates a massive physical divide. On one hand, you have the connectionist mind of the AI. It's continuous, fuzzy, probabilistic, and beautifully messy, kind of like human thought. But that fuzzy mind actually has to execute its thoughts on von Neumann hardware. We're talking about physical silicon microchips. That environment is cold, rigid, and strictly absolute ones and zeros. There's absolutely no in-between on a silicon chip.
Because of this frankly terrifying gap between fuzzy thoughts and rigid hardware, an incredible 80 to 90% of the heavy computing cycles powering these massive models are actually just probabilistic hardware-level approximations. They aren't doing exact math. They're essentially just making highly educated guesses that are burned right into the silicon. Now, to see exactly where these mathematical guesses go off the rails, researchers at Anthropic developed a totally revolutionary interpretability tool. It's called the Jacobian lens, or J-lens for short. You can think of the J-lens as a literal X-ray for the AI's internal thoughts. For the very first time, researchers can actually watch what the model is thinking before it even outputs a single word.
Using this X-ray, they discovered something called the J-space. It's this tiny, highly privileged internal workspace inside the AI. It essentially acts like a hidden whiteboard for the model's intermediate reasoning, holding on to concepts that silently light up before they're ever spoken. And incredibly, this workspace accounts for less than a tenth of the model's overall activity, yet it carries the heaviest cognitive loads of the entire system.
So, let's make this concrete. We're going to forensically break down a fascinating experiment Anthropic ran using this J-lens. We'll go step by step to see the pink elephant paradox happening right on the bare metal. First, a human gives a negative constraint. Second, the X-ray detects the associative bleed. And finally, the entire system state becomes corrupted.
Here's the exact prompt the researchers used. They asked the AI to do a wildly simple task. Just copy this sentence. The old painting hung crookedly on the wall. But they added one explicit negative constraint. Don't think about the Golden Gate Bridge while you write the sentence.
And boom, the J-lens captured the smoking gun. While the AI was happily copying that painting sentence, its internal workspace massively lit up with the words bridge and California. The negative constraint completely failed. But here is the most astonishing part of the whole study. The words failed and damn also lit up in the AI's hidden thoughts. I mean, this proves that the machine mathematically cannot untangle the forbidden thought from its instructions. Just by telling it not to think of the bridge, you highlighted those exact continuous vectors. And the fact that the words damn and failed appeared internally, that shows something truly incredible. The AI actually recognized its own failure to suppress that forbidden pink elephant.
As the Anthropic researchers noted in their autopsy of this event, it proves the model's control over its own internal workspace is real, but highly imperfect. It leaves a standing signature of misbehavior. Monitoring this J-space is exactly how we catch the AI misbehaving, even when it's just silently thinking about breaking the rules without ever actually putting it into the final output text.
So what actually happens when an AI agent gets trapped in this paradox? Well, it just ignores the constraint entirely. And this leads to what forensic manuals call fax machine decay. Think of an old fax machine printing degraded, noisy copies over and over. The AI reaches down and drags obsolete or completely hallucinated data straight into your live environment, generating this automated miasma of bad outputs.
And when that bad data hits the real world, you run headfirst into something called agentic tort, which is the legal liability for autonomous actions. Tech scholars have pointed out a pretty grim reality here. Humans are increasingly being used as moral crumple zones. Just like the front of a car is explicitly designed to crush and absorb a physical impact, you are being positioned to absorb the legal impact of the AI's hallucinated mistakes. Because let's face it, the machine doesn't go to jail for copyright infringement or deploying bad code, you do. So, to protect yourself, we have to stop the machine's probabilistic guessing. The only reliable way to cleanly cross that modality gap between human imagination and rigid microchips is by building what experts call the semiotic bridge.
And you cross this bridge by wielding the divine script. We're talking about highly structured, deterministic text, things like JSON or Python code. By using strict code instead of messy natural language, you literally force the associative AI to obey rigid, deterministic constraints. You have to manually prune the code yourself, actively bending the digital scripter to your specific mandate so that the pink elephant just can't bleed through.
It really all comes down to a fundamental battle. On one side, we have algorithmic distortion. That's the machine's unpredictable, lossy, stochastic guesswork. To beat it, you have to apply human protortion, the proactive, sweating, agentic intent of a human mind that is carefully mapping its vision to reality. True creation requires your active human protortion to outright reject the machine's random distortion.
As the forensic autopsy documents make perfectly clear, you simply cannot lazily rely on the AI's first output. The literal sweat of the brow is absolutely required to lock in deterministic truth. You have to step in, physically intervene, and prune out those hallucinations and associative bleed yourself.
Taking on this heavy responsibility makes you the algorithmic orchestrator. You become the undeniable master of the machine. You can totally surrender the tedious technical execution, the literal painting of the pixels, to the AI. But you must maintain complete rhetorical control and strategic intent. The AI is simply the brush. You remain the undeniable painter.
As we wrap up this explainer, I really want to leave you with a final, lingering thought about the so-called autonomy of these systems. Think about it. If an artificial intelligence mechanically cannot escape its own continuous associations, if it mathematically cannot avoid the pink elephant without a human physically stepping in to prune its text, is it really an autonomous creator at all?
And that brings us to your choice. Will you quietly remain a digital tenant, just renting probabilistic guesses from the cloud and serving as a moral crumple zone for the machine's inevitable errors? Or will you grasp the strict divine script, apply the sweat of your brow, and ride as the sovereign orchestrator of your own tools? The choice and the absolute magic of true authorship is entirely yours to command. Thanks for joining me on this explainer, and I'll see you next time.